In this problem, I will be converting a rate using a formula and a dimensional analysis approach. We are told that methoxin, 500 milligrams, needs to be infused every 8 hours. We are told that it is available 1 gram in 100 milliliters of NS. The calibration that we are using is 20 drops per milliliter, and our infusion time is 30 minutes. We need to determine at what rate, in terms of drops per minute, should we set for this infusion. Using a formula, I know that I would need, in order to figure out a rate in drops per minute, I would need the volume to be infused, I would need to know the drop factor, and I would need to know the infusion time in minutes. I am given all of that information in this problem. The volume, how many milliliters needs to be infused, is given to us, but it's not 100. In this problem, I am told that I need to give 500 milligrams. And what is available is methoxin. It's available 1 gram in 100 milliliters. So what I need to first figure out is how many milliliters will I be giving. So to determine that, I can use either a proportion or I could use dimensional analysis. I'm going to just use a quick proportion here. If I need to give 500 milligrams, I don't know how many milliliters that is. But what I do know is that we have 1 gram contained in 100 milliliters. I know 100 milliliters contains 1 gram, which is equivalent to 1,000 milligrams. So by cross multiplying here, what I figure out is that I would need to, in the infusion, the volume that needs to be infused is 50 mLs. So now that I know the total number of milliliters to infuse, the drop factor, which is given to me, is 20 drops per milliliter, and the time, infusion time, 30 minutes, I can plug that in. So my rate can be calculated. I know there are 50 mLs that need to be infused. I know the drop factor, in this case, is 20 drops per ml. Now, you may or may not, it's up to you, whether you want to put in the units. Sometimes that can be a little bit confusing, but I'm going to use it in this example to help keep everything straight. So I have the volume, the drop factor, and now the time. The infusion time is 30 minutes. The most common mistake is students thinking that this is going to be 8 hours because that's what it says at the top, IV every 8 hours. This is how often this order should be repeated. This is not the infusion time. The infusion time is 30 minutes. So now that I have plugged in all of the variables, or the values for each of the variables, I can figure out what I have here. So 50 times 20, and if you take 50 times 20, and then you divide that by 30, you're going to get 33.3. And this is going to be 33.3 repeating, which we know, if we're talking about drops per minute, we're going to round this to the nearest drop. So that would be 33 drops per minute. Using a formula approach, if we know the variables, the volume to be infused, the drop factor, and the time, the infusion time, in minutes, we can plug those values in and simplify. What made this one step a little bit more complicated here is that we needed to figure out that volume. In the dimensional analysis approach, we know in this example 500 milligrams needs to be infused. 500 milligrams needs to be infused over 30 minutes. I need to somehow convert. When I am done with my dimensional analysis, I'm going to need drops in the numerator and minutes in the denominator. I already have a unit of minutes in the denominator. So what I need to do is to figure out how I can convert milligrams into drops. Well, I know I can go from milligrams to grams. And the reason I want to go to grams is because then I can figure out how many milliliters that is. So I'm just mapping this out. And then using the drop factor, I can go from milliliters to drops. So I'm just mapping out exactly what I'm going to be doing with my conversions. So the conversion from milligrams to grams, I know that there are 1,000 milligrams in 1 gram. I can now convert the grams to milliliters. And what I'm finding here is how many milliliters the patient would receive. In this problem, I know the ratio is 1 gram to 100 milliliters. This is not always the conversion factor you'll use, but it's what we're using because that's what is available to us. And then finally, if I wanted to convert milliliters into drops, I know in this example, every 1 milliliter will be broken down into 20 drops. So up top, what I'm going to have is I'll have 500 times 100 times 20, and maybe I'll put this down here just because I ran out of space there. 500 times 100 times 20 is going to be 1 million. 1 million if I multiply all the numerators, and if I multiply all the denominators, I will have 30,000. So if you take 1 million and you divide it by 30,000, you will get approximately 33.3 if you round that to the tenths place. But we know that that needs to be rounded to the nearest drop, which would be 33 drops per minute. Both of these approaches are acceptable. I personally would maybe aim for the dimensional analysis because we know that any sort of conversions that need to be done can be done within the dimensional analysis. Using a formula approach, using this formula, you must have each one of these pieces. So even before we could have used the formula, we had to figure out what the milliliters was. That is why those problems, you really need to be careful about what you're plugging in for each of those variables.